In today's video, we're focusing on how to teach comparing fractions. Just like in our other videos, our goal is to help you understand the key ideas behind fractions and give you practical teaching strategies that help students truly make sense of what fractions mean, not just memorizing procedures, but genuinely understand them. Comparing fractions and understanding equivalent fractions are built on the same key ideas. That's why these two concepts are included together in the standards students are expected to learn. There's a link in the description below to the core standards that we'll be covering today. And if you'd like a deeper look at those foundational ideas, you can watch our previous video on equivalent fractions here or in the description below. On to the lesson. Just like with equivalent fractions, when we're comparing fractions, students need to understand that we are comparing sizes. And those sizes are determined by the division represented by the numerator and the denominator. One important thing to watch out for when teaching fractions is whole number bias. Whole number bias means that learners continue to apply the rules of whole numbers when they start working with fractions. They tend to overgeneralize whole number thinking and apply it to fractions, even when it doesn't make sense. As a result, students often focus on the numerator and denominator as two separate whole numbers. But the size or amount represented by a fraction is determined by the quotient, the division of the numerator by the denominator. So we can't treat the numerator and denominator separately. Instead, students need to make sense of them simultaneously, understanding the fraction as a single value. The key is to reinforce the meaning of written fractions. The denominator tells you the size of each piece when the whole is divided into equal-sized parts, and the numerator tells you how many of those unit fractions you have. To support this progression and provide the right foundation, it's important to give students opportunities to notice and understand this pattern. One effective way to do this is by comparing fractions with the same numerator or same denominator. This also aligns with the progression outlined in the Common Core content standards we talked about earlier. Provide students with a set of fractions, some with the same denominator or some with the same numerator, and ask to compare them. As you do this, support students with hands-on materials, virtual tools, or drawn fraction models. Check the description for links to some of these useful tools. Again, the key idea you want to highlight is that we are comparing sizes. Help students notice that when the denominator gets bigger, the size of the unit fraction gets smaller. For example, 1/3, 1/4, and 1/6 are clearly different sizes when shown visually. This point is especially important because many students assume that a larger denominator means a larger fraction. When teaching, we need to make sure students can see the corresponding sizes of the fractions they are comparing, not just the written symbols. That's why visuals and manipulatives should be part of your instruction, especially when introducing the concept and when supporting students who are struggling to understand. Comparing the sizes of fractions also requires careful attention to the whole that the fractions refer to. Students often make mistakes, such as drawing a different sized one whole for each fraction they compare. When that happens, the comparison no longer makes sense. Another key thing to remember when teaching comparing fractions is to have relatable context. Many resources used to teach comparing fractions have no context at all, which is a huge problem. It's much harder for students to make sense of what fractions actually represent when they're just looking at numbers on a page. Try out this word problem to provide that meaningful context. Yasmin baked 4 rectangular pans of brownies for a school event. Each pan was the same size. Each pan had a different topping. After the event, Yasmin noticed how much of each pan the class ate. 3/8 of the strawberry brownie pan, 3/6 of the icing brownie pan, 3/4 of the chocolate chip brownie pan, and 1/2 of the peanut butter brownie pan. Which pan did the class eat the most of? Since the goal is to emphasize that comparing fractions is all about comparing sizes, we've created a problem that gets them thinking about size in a natural way, the amount eaten from each pan. Give your students time to really work through the problem. Don't rush this part. Make sure you provide physical fraction bars or printed out fraction bars so they won't accidentally partition them unevenly and end up with the wrong conclusions. As students share their solutions, listen carefully for misunderstandings. Are they only comparing the denominators? Only the numerators? If students are focusing on just one part of the fraction, that's often a sign of whole number bias. Let's use what we know to solve this problem. To find out which pan the class ate the most of, we can use fraction bars or other visual tools to compare the sizes of each fraction. Remember to write the fractions next to the fraction bars to further establish a connection between the visual and written form. And make sure to use the same whole when comparing each fraction. As we can see, 3/4 is larger than the rest of the other fractions, meaning that the class ate most of the chocolate chip brownie pan. In conclusion, when teaching comparing fractions, Make sure to start with context, not just numbers on a page, emphasize that comparing fractions is all about comparing sizes, watch out for whole number bias, and utilize written fractions along with visuals and online tools to help build understanding. As always, if you liked the video, leave a like and subscribe to Science of Teaching Math if you haven't already, and leave a comment letting us know what you'd like to see next. Thanks for watching!